discrete graph, okay? Okay, so you have 0, 1, you have 1, 3, 2, 5, 3, 7. So if I go ahead, 0, 1, 1, 3, 2, 5, 3, 7. You're gonna leave it like this because this is called a discrete graph. You can just call it discrete. Continuous is what you guys are used to, where you connect the dots. That's continuous. Discrete is, if you guys go into stats, you'll talk about it a lot more with your teacher. That's it. That's your graph, right? And then if you guys are looking at the graph, what did I do? Slope in pink. You guys know that slope is m, and you know it's plus 2, and so if you know it's really plus 2 over 1, right? So if you guys are looking at the points, see how from one point to the next it goes up to right 1, yeah? Up to right 1, up to right 1. So like your graph should kind of match this recursive or explicit. Is that okay? Yeah, right. Up 2 units, right 1, up 2 units, right 1. And so if you wanted to keep going on your graph, it would go up to right 1, well, up to right 1. Is that okay? Okay, your y-intercept, I'll do it in orange. So then let me kind of move it a little bit. Y-intercept is your b value, right? So let's do this. And that is, remember, every y-intercept is 0 in that b value, right? The x value is always 0 because it's where the line or the data crosses the y-axis. Oh my god, I almost said x. So here, that would be right here. That's your b right there because it's where it crosses this y-axis, right? Okay, so keep going, or you guys okay? Okay, so for this table then, we're going to kind of repeat everything, but we're going to separate the recursive and the explicit from this little table. Okay, so what it is then is this is really what you start doing. This expression one, I don't make you guys do on a quiz or a test. It's just here so you guys can kind of think of what you guys do naturally in your head. Okay, so if I rewrite 3, 5, 7, and then you want to be able to identify it's going up to, and so with this information, you should be able to write 2 equations, and this is the main idea, is can you write a recursive or an explicit function or equation given a set of data points, right? Even though it started off from figures, you should be able to go from here and then everything down below. Up here is more of just kind of getting you guys to figure out what we're doing, okay? Okay, recursively. Students always give me one. They'll forget the first one that I'm going to write the initial term, and you end up getting docked. So just make sure with the 2 of you, when you guys quiz, you give me both, not just one of them. You have to give me the initial term, and this is the one that students always leave off. The initial term is the very first piece of information that's given to you. Step 0, 1 star, right? Which is f of 0 equal 1. You have to give me this. Not f of 1, not f of 2. You got to give me the first piece of information given to you, okay? And then typically then, you know that this is then the general term is this right here. So then any term forward, you look at your prior term and you add 2. Here, I'm messing that up. 2. So if we're asking for recursive, I need these 2 things always. Not just one of them, both of them. Okay, what's explicitly? For linear and exponential, you guys are amazing at this. The quadratic, this will be extra credit when we're doing quadratic, okay? Actually, I think both of them are. I can't remember. I know for sure this one. All right, and it's just your linear pattern. So just like we solved right here, we solved it right. It's just, so if you were to give me y equal 2x plus 1, you would get perfect credit, but seeing how everything's an f of n, it would technically be 2n plus 1, but I won't dock you. You can give me either one. Yeah, it's always loud this way. They're always collecting the trash. And then I'll pause it when you guys are ready. And then I'll have you guys graph these three lines, and then I'm gonna come around and write your names on a seating chart. It's just a sheet of paper. Yeah? Okay. 8, 14.